All right, Math 10, we're going to be talking now about functions. And we're going to reviewing functions and understanding functions through these four different ways to view relations. It turns out that functions are just special relations. So a relation, remember, is a set of ordered pairs. So a function is just a special type of set of ordered pairs. So it's also going to be a set of ordered pairs, but there's rules about the domain and the range. So let's take a look specifically at the rules for functions. So a function means that if it's a relation is going to be a function, that each element in the domain corresponds to exactly one element in the range. So if this was, for example, let's go down here. For example, here is a function, looking at it in terms of a mapping diagram. Notice that every single value in the domain has exactly one arrow coming out of it, right? That means if each one of those things has one arrow, that means that each element in the domain, each one of these dudes here, these numbers here, corresponds to exactly one element in the range. So they all have one arrow coming out of them. That's what it means for a relation to be a function. That's it. That's all it is. Nothing really more grand or fancy than that. And that's the story. To see it in a mapping diagram, you're basically looking to see if there's just one arrow coming out of each element in the domain. Here's an example of something that is not. This is over here. This relation here is not a function because you can see there's two arrows coming out of this one x value, and that's not how functions work. That's a relation. Yes, this over here is a relation, but it is not a function because there's a special rule about functions where every x has to match to only one y. There is a second type of function that has even stricter rules, the one-to-one function. So in the one-to-one function, basically the rule is that every one value in the domain is associated with one value in the range and vice versa. So in other words, you can't have multiple arrows coming into or out of either the domain or the range. So this is an example of what a one-to-one function looks like. There's an arrow that goes from 1x to 1y, and they never cross. They never end up pointing at each other or coming out of each other. Like that's just always kind of one. A value maps exactly to one value from domain to range. So those are two sorts of functions there. There's the general function. It's okay for x's to point to the same y. And then there is the one-to-one function where an x has to point to just a unique y value each time. And then over here, this is, again, just kind of repeating myself at this point, but this is a relation, but is not a function because there's x value maps to more than one y value. So that makes it not a relation. Does that make sense? I hope it makes sense. If it doesn't make sense, I wouldn't blame you. It's pretty confusing stuff. But, those are sort of the definitions, and I would recommend maybe just reading this over and try to express it in your own words if you can. What is the rule about whether something is a function, a one-to-one function, or just a regular relation that isn't a function? So we're going to take a look at some examples of questions like that. I'm going to kind of skip over a few of these things. We'll jump right into it. In exercise question 1, they're just asking you for the definition of a function, and I'll let you look at it. And if you don't get it right, then feel free to ask me what you think it is, or what you got wrong and why it isn't that particular one. I'm going to skip question 2. Don't worry about question 2. Some of these are okay, but some of these are also a little bit worded strangely, and I don't love the wording in some of these questions. They don't necessarily all make sense. Some of them are fine, but some of them are a bit weird. So I'm going to just move on. Here we go. So here is an interesting question, though. Question 3 is asking, hey, are these sets of ordered pairs functions? So remember, what is a function? A function is a relation, a set of ordered pairs. So these are all sets of ordered pairs, great. But there's a special rule, and that is that each x has to correspond to 1y. So in these ordered pairs, we better not see a duplicate x value. If we see a duplicate x value, then we know it's not a function. That's the story. So let's take a look. Here we have, these aren't numbers they're mapping names together, like first name, last name. Okay, sure. So we have Snow and White are matched together. Howdy and Doody, Jack and Frost. So I'm going to say yes, this is a function because each x value, Snow, Howdy, and Jack, are all mapping to different values. Like I'm not getting Snow in multiple ordered pairs, or Howdy or Jack for that matter. So that's how I'm discerning the answers. I guess I could also say this is a one-to-one function. Each one of these names corresponds to exactly one other name, and they're never in between meeting. Let's go on to another one. We have now Sue Smith, Bob Smith, and Joe Smith. So this is also a function, yes. Because, again, there's no duplicate x values. Sue, Bob, and Joe, they're all different names. They happen to all map to the same y value. Smith, Smith, and Smith is always what they're mapping to. But that's okay for a function. It's okay if the y's match up. Functions don't mind. However, this is not a one-to-one function. So it's a function, but not a one-to-one function because there's not unique names for both the x's and the y's. Yeah, is that making sense? What would be an example of one that is not a function? That would be C. C is not a function because you see the same x value appearing multiple times. So the x value cannot map to multiple values. That's not a function. It's a relation. It's not a bad thing. It's just not a function. When it gets to numbers, like question D, that's a little, it's not trickier, but you do have to look fairly carefully. So here we see we have a 3, a -3, a 5, and a -5. Those are all unique x values, so that seems okay. So I would say yes, this is a function because there's no, x's that are, there's no, what's the word I'm looking for? There's no redundant x values. There's no sort of doubling up or tripling up or whatever of x values. So that works out nicely. So yeah, take a look at the rest of these and see if you can identify whether they are functions or not functions. And check the answers as you go and let me know if you have questions about that. I'd love to answer your questions. Next, we're going to be looking at, in the next video, how do you see if a graph, looking at a relation, and you're seeing it as a graph, how do we tell if that's a function or not? So that's going to be in the next video. Okay, thanks everybody.